Hi, I'm here this morning to help you with your math lesson because I'm the math teacher. Lesson 10 is all about adding and subtracting real numbers. So let's do just a view of which numbers are the worst. Back in lesson 1, we made some categories, okay, that kind of thing, and we kind of built up the number system from starting with 1, 2, 3, then adding 0 onto that, and then adding the opposites of the positive numbers. We got the negative numbers, that would be the integers. And then we said, well, all of those could be written as fractions. That was called a rational number. And then lastly, we have irrational numbers, numbers that cannot be written as fractions, usually things with square roots, like square root of 2 and square root of 3. Or if you tried on your calculator to get a number for that, it would just keep going forever. So you can't write it as, you can't change 3.14, etc., with pi to 3 and 1400ths. It's really not exactly that. So today, the main types of numbers that I want to think about that are real numbers that we're going to be playing around with, though we could do these, would be positive and negative fractions and integers. Integers are like these numbers here, like our counting numbers and our negative numbers, opposites. And the easiest way to talk about real numbers is to use a number line. And we're going to call this the real number line. I don't have everything marked on there, but I could put 1/2, and I could put square root of 2 in there somewhere, right about there. I could put any positive or negative real number on the number line. And today we're going to talk about adding them and subtracting them, maybe a couple of different ways to think about it, how to verify these things with the calculator, and then we're going to do some ranking. We're going to say what's the least, what's the greatest, and want to make a distinction between how far to the left or how far to the right on the number line that is, as opposed to absolute value, which we've done before. When you think about that, greatest sounds different than what you're thinking about on the number line. So if you've got your book, you've got a notebook to write some notes down, that'd be great. Lesson 10, page 47, adding and subtracting real numbers. Now, our book suggests that we begin by writing any problem with pluses and minuses and signed numbers as addition only. And I really like that. I would like to think that there is no subtraction. Right? It's like in the Matrix where the kid has the spoon and he's like trying to get him to bend the spoon. He's like, there is no spoon. There's no spoon. And as soon as they figure out there's no spoon, then it's easy to do, right? Something like that. So there is no subtraction today, only negative numbers. Okay, so no subtraction, only negative numbers, and all we're going to be doing, instead of adding and subtracting, we're going to be combining. We're going to be putting them together and seeing what the result is. That might be a different way of thinking about this than you're used to, but I find it very helpful. It kind of gets us away from talking about, well, I've got 3 apples and you take away 2. Because today we're going to have 3 apples and take away 4, right? So let's get a little bit abstract and think about negative numbers and positive numbers and putting them together. We're going to add everything. Though some of the first problems, they're not kind of set up that way. But anyway, let me erase some of this stuff. Let me hit pause. I'm going to erase some of this stuff and get the first problem set up. I had peanut butter this morning. Now, why'd I just say that? That's for you to think about. Our first problem, example 1a, deals with fractions. 1b is going to deal with decimals, numbers with decimal places. They're both rational numbers. Okay? You can write either of them as fraction if you really, really wanted to. And what we got here first is a negative 1/5 and 3/5 take away 2/5. We're going to probably fix that. and then take away a negative 4/5, or subtract a negative 4/5. And you've had enough math to know some things about signs, that you got two signs sitting right next to each other. You can resolve them. You can turn them into one sign. And so we need to do that with the very last piece of this thing. Now I want you to also know that with math, you don't have to start over here on the left and work all the way over to the right. You can pick where you want to go because of the commutative and associative properties. Commutative means you can move adding pieces around, and associative means you can group things however you'd like. So I've got these two negatives right next to each other, and this is actually multiplication. So two negatives together, you get negative, another negative makes a positive. I'm going to rewrite this as plus 4/5. Now the book suggests, they got a hint in there, it says use the rules below for adding integers. This is on page 47 on the left. Number 1, like signs, add and keep the sign. And so here's what I'm going to do. I'm going to group things. I'm going to move them around and group them together so that all the positive numbers are together and all the negative numbers are together. Okay? So that means this is a 3/5, positive 3/5. I'm going to put it right here next to my new positive 4/5. So I got 3/5 plus a 4/5. And then I'm going to take my two negative pieces, this piece and this piece. I'm going to put them over here. I like putting the negatives last because it's kind of like more convenient for subtraction if that existed anymore. Now I'm going to group them. I'm going to say here's my positives and here's my negatives. I'm going to put them together first, and then I'm going to go from there. So all I did was I moved the pieces around. That's totally legal. Okay, 3/5 and 4/5 make 7/5. That's just simple adding with like denominators. So there's my new combined answer here. Now both of these are minuses, or negatives, I should say. So you got a 1/5 and a 2/5. You're going to add those up together. A negative 1/5 and then 2/5 more is 3/5. So we have minus 3/5. Now I said there was no subtraction, so technically maybe I'd do this, kind of make it a short minus sign into a negative. 7/5 and negative 3/5. Or if you would prefer 7/5 minus 3/5, 7 minus 3 is 4. So there's our final answer, is 4/5. See, that's one way that you can think about it. You're allowed to move the pieces around. You're allowed to combine the signs. If there's two of them in a row, you can make them into one. Group the positive ones, group the negative ones. We combine the negative ones. 1 and 2 makes 3. They're both negative, so it's negative 3. The 3 and the 4 makes 7, a positive 7/5, and then we can just subtract straight across. 7 minus 3/5 is 4/5. Okay, that's one way to think of it. Let me show you another way to think of the same problem. And that would be using something called vectors. And the number line, the real number line. Okay, so negative things are always pointed to the left, and positive things mean we're going to travel further to the right. So we could do it this way. We could start here, and we could go this way 1/5 to negative 1/5. We wouldn't get very far. We get like right about there. And then we're going to go this way 3/5 from here. So we go 1/5 and a couple more fifths. We'd end up at 2/5 by adding 3/5. Now we want to go backwards 2/5. That's going back this way. Now we're at 0 because we were at 2/5. And then lastly, we're going to go backwards a negative, which we already said was adding 4/5. We go this way, we end up at 4/5. That was the answer, right? So you can think of it as traveling to the left and traveling to the right. The cool thing about these arrows is that I can just put them all together. I can actually take all of the ones that go backwards, this 1/5 and this other 2/5, and I can combine them together to get totally that I went backwards 3/5, and that's what we did in the previous problem, right? And then we can put together all the forward arrows, which was, if I start from the same place, which was a 3/5, and then we went another 4/5. Another 4/5. So altogether we had 7/5 going in the positive direction, and we can combine those two together. We can say we went this way 3/5, and then we went this way 7/5. We ended up at 4/5. So you can think of it as traveling left and traveling right upon the real number line. Either way works, especially when we're counting up positives and negatives and grouping them together. Okay, we're going to do decimals next, so give me a moment here. I'll set up the next one. Okay, I've got our decimal rational number up there now, a real number, if we want to make it a little bit bigger. And again, we find that we've got a negative, we've got subtraction, which we could say is plus a negative. We can group our positives and our negatives together. So we'd have our 3.16, and let's also put that together with our 5.6. Those are all our positive numbers grouped together. And then we've got negative 1.22, or plus a negative, and then we got another negative here. So we put these two together and kind of group them, and we group these. So at that point, you might just want to use your calculator to make sure that you line everything up right and get a correct answer. You can do that in your head. You'll get 8.76 on the positives. And then over here, we're going to add these two quantities together, and it's going to be minus. So we get 5.95. Okay? Calculator is probably the best way to round that one off, or you can line them up vertically. But I just did that. I put the positives together, put the negatives together, collected them all, and then I've got a simpler problem at the end. But again, all I did was move the pieces around to make it a little bit more convenient for me to do that math. Right, before I show you the stuff on the calculator, let's look at example 2, ordering rational numbers. I think the best thing for you to do on problems like example 2 is to draw yourself a number line first. And the reason for that is because, again, I talked about not thinking today about absolute value. If you recall, absolute value is like how far away you are from the origin, either left or right. It's just a distance, okay? An absolute distance. So -3 absolute value is a bigger distance away from 0 than 2, positive 2. And so we're not doing that today. Today we're going to like go from left to right, or from least to greatest. The further left you go, the number becomes more leaster, okay? Leastester. And the further you go to the right, the greatester you get. So if we've got a list of numbers and they gave us 7/8 and -2 and 0.125 and 1/2. We have a mixture of decimals and fractions, and we need to know where they all fit. If you'd like, you could go ahead and do the division on your calculator, but probably you're going to have to put a decimal point in there for your calculator to give you a decimal. Or use the math button and find the thing that will convert it over to a decimal, and then you can compare like with like. But if you know that that's almost 1, it's really not that hard. We could put a 7/8 right about there. -2 is over here. And then you've got a very small number. It's a little bit bigger than 1, right? So it's going to go somewhere over here. And then 1/2 is right there. So from left to right, from least to greatest, we have -2, 0.125, 1/2, and 7/8. And that's what they want you to do. They want you to order those things from the furthest to the left, the furthest to the right. The only other thing that they ask you to do, like in example 3, is to do our original problem from example 1 twice. They give you one that they want you to come up with an answer on the left and another one with an answer on the right, and then you get those three choices that either those two values value on this side are either equal, this one is small and that one's big, or this one is big and that one is small, or bigger, smaller, if we're going to do comparative here because there's two things. You see that down there? Those are your only choices. You have two little problems to do, one on the left, one on the right, and you have to decide which one has the greater value. Which one is further to the right on the number line than the other one that's further to the left on the number line. Okay, so I'm going to do one more thing with you. I'm going to show you the difference on the calculator between a negative and a subtraction problem, and then using parentheses and all those other things, fraction bars and whatnot, in order to verify an answer on the calculator. Hang on. Hey, friendly neighborhood math teacher still here. We've got our calculator up, so I'm going to show you how you might go about typing these things out so you can compare them. I'm going to go ahead and do letter D on page 49. Complete the comparison. So I'll just do kind of the left side and the right side, and we can compare the answers. So first of all, let's go ahead and we're just going to start typing this sucker out. You got 3.2, and then we're going to give it exactly what's got here, plus, and then when it has in parentheses, the parentheses are right here above the 8 and the 9. Going to open parentheses, and it says negative 2.8. Do not use the subtraction sign. Use this sign down here in the parentheses. That's negative. It's a little bit shorter than a minus sign. So negative 2.8. And then we're going to be honest here and close the parentheses. And now the next symbol is subtraction. You can tell there how the negative is like a little bit higher and the subtraction is a little bit longer. 5.2, enter. So there's the first part of our problem. We get a negative 4.8, and now we're going to compare that with the, what's on the other side, which has a bunch of fractions. And the best place to get a fraction bar is right here to go alpha x. And it gives us this math print thing with numerator, denominator, and we can type in our 7 and then arrow down 12. Then to get it out from the denominator, we have to arrow over, and we can type out the rest. So then we have, what does that say? Plus 5/12. Mine says plus 5/12. I'm going to go with that. Plus alpha x, again for the fraction bar, 5/12, arrow over again. And then we have, I'm going to type exactly the way that has there in the book, plus, use parentheses, and then that's a negative. Negative. Another fraction, alpha x, and the fraction is 11, arrow down, 12, close the parentheses. Oops, hang on, that was no good. I gotta go back, arrow back, delete that sucker, arrow over, parentheses. There we go. It looks exactly the way it does in the book, and I'm going to get an answer for that, and now I can compare that negative 4.8 and 1/12. Negative 4.8 is further to the left than 1/12. 1/12 is to the right of 0, so we can figure out which thing we can use there. So again, fraction bar, minus sign, negatives, they look different. Make sure that you know how to do that. And I'll give you one more, and that would be if you want math, you can change something into a fraction or into a decimal. Also, you can go alpha F1, and you got your fraction stuff there too. All those are like nice quick tricks you can get to stuff. All right, that's all for that. We'll see you in class. Good luck on your homework.